Good afternoon, everybody. Welcome back. This is the last time I'm going to get to greet you as a team today, but we'll get to see hopefully everyone at the House of Blues tonight. And I just wanted to comment because I didn't make the run this morning, but I did make the run last night. And I had a calm enough dinner, and then I decided to walk home, which was a mistake. Walked down Illinois Street and kind of ran into a few parties that were spilling out onto the road. And it was more like Mardi Gras than an F5 event, but it was amazing. And this group definitely knows how to party. Is anyone from the Latin America team in here? Yeah. In retrospect, that might have been a mistake visiting that party. But it was a great time, so thanks for your hospitality. I don't know if my Spanish got any better, but I'm absolutely sure my English is worse. So you'll stick with me, hopefully, here this morning. Or this afternoon, whenever it is. The story will be the same, though, and I do have a fun story to share with you. I hope you'll get a lot out of it, but it's a way that I wanted to think about how we could introduce the cloud and give some basis for it, other than the IT fundamentals of it. Why has it become so important? And to do so, I wanted to go back and just reflect on a couple of things that I think you'll find interesting. I hope you will. And we have to go back in time to 1971 to really, truly appreciate this story. Now, 1971 was I was 5. So I don't have a lot of memory. A lot of people don't have memory of the 70s, but it was a very interesting time. But if you look at some of the things to give you some benchmarks, the fastest car in the world at that time was the Ferrari Daytona, the 1971 Daytona, which actually went as fast as 174 miles per hour, wicked fast. The tallest building in the world wasn't quite complete, but it was right here in Chicago, the Sears Tower, and it was reached into the sky at 1,729 feet. Just I think it was almost 20 years. It was the tallest building in the world. And also in 1971, a little company in Northern California called Intel Computing, one of our sponsors here today, for the first time released the first commercially available microprocessor, the Intel 4004. And the Intel 4004 had approximately 2,300 transistors on it, and each of those transistors was just barely larger than a human red blood cell. Now, as everyone knows, computing has advanced immeasurably since then. In fact, chips have gotten faster and faster and faster, very much in line with something called Moore's Law, which I'm sure you've all heard of, but Gordon Moore was the co-founder of Intel, and he postulated, it wasn't really a law, but more a rule of thumb, and he had this published in Electronics magazine at the time, and it was a notion that every 2 years or so, he postulated, our capabilities in the foundries and in our chip manufacturing would get better to the point that you'd be able to double the number of transistors in the same space on the chip. And this really went on and on and on. This capability lasted for almost 40 years, growing geometrically. And every 2 or 3 years, you saw an entirely new family, an entirely new cast of microprocessors entering the market. Now, if you take this forward almost 50 years now, 45 years, the Intel Skylake processor today has almost 1.75 billion transistors on it. And its capabilities are 400,000 times what the Intel 4004 was able to do. And this number is so big, it's really hard to believe. But if you put it back into the physical world, and remember that Ferrari Daytona. Well, the fastest car in the world today actually only goes about 50% faster. This is the Bugatti Chiron, and I've got to get one of those someday. That's a beautiful car. but only 50% faster in those same 40 days, same 40 years. If you actually look at, the tallest building in the world, advance the slide, please. We're having a technical, there you go. This car is so fast that it would actually be able to transit the world in less than 1 second at its current speed, at the speed if it grew at the size of the integrated circuit. And then also, that's almost 1/10 of the speed of light. If you look at instead the tallest building in the world, for instance, the Burj Khalifa, for any of you who have seen that in Dubai, that building is also about 50% bigger than the Willis Tower, the Sears Tower here. But today, if that had grown at the same capabilities as the integrated circuit, it would reach halfway to the moon. It's really hard to believe just how much progress has happened in the integrated circuit and in the microprocessor. And perhaps the best example is, if you think about it today, the smartphone that so many of you have in your pocket, that 3 billion people on the planet have in their pocket, a smartphone. That phone today has more computing capability than the largest supercomputer, room-size systems of the 1980s. In every single pocket. Now, I reviewed a couple of examples yesterday about how all of this technology is changing the way we work. It's changing the way our companies perform. But think about the profound impacts that Moore's Law has had on the types of companies that are in the Fortune 500, for instance, on the type of work that we do every day when we go to work, and on our personal lives as well. Every dimension of the human experience has been changed by this development. And yet, after almost 50 years now, it seems that Moore's Law may be coming to an end. And why, you may ask, and the reason is very simple. Because if you look at that Skylake processor today, with its nearly 2 billion transistors, each of those transistors, in many cases, only as wide as 150 atoms. 150 atoms. And the space between, the junction between many of those transistors is as little as 30 atoms. It is a reality of the nature of matter, the quantum element of matter, that very soon we will simply not be able to pack transistors any more tightly onto a chip. I think about computing, and I don't know what you think about first, but whether it's a PC or a tablet, as I'm showing here, what are the things we think about, at least in the past when we would buy those? How much memory does it have? How fast is the clock speed? What kind of storage do I have? What types of interfaces do I have? All these questions about the hardware characteristics of that device. And that's largely what differentiated one device or another. But what's happening today is very different. If Moore's Law is really coming to an end, how do we continue to gain power and capabilities out of these devices? And what I would postulate to you today in the room, and I'd ask you to think forward, it's that it is actually becoming the capabilities of the cloud, which are adding life and horsepower and utility to the computing devices of today. There's lots and lots of examples. I'll just use a few. I have an iPad with me. I travel with it. I have no idea what kind of clock speed it has. I don't know I don't think it has a hard drive. I don't know how much storage it has. It doesn't even have a USB port. But I can sort through thousands and maybe millions of emails. Of the more than 1 billion websites out there in the world, I can visit any one of them from this device. And I can search through the 2 megs on average of content that each of those websites has, I can sort through that in a flash. I could only do that with the cloud. Another element to think of this device, now consider this device. I don't know anything about its hardware characteristics. But what I do know is it has a limited set of applications on it, and that doesn't bother me at all because I can leverage all of the applications that are in the cloud. For instance, if I want to do a simple mapping function to calculate the shortest route, my device doesn't need to be able to do that. The cloud can do that for me. Same thing with weather. The device doesn't need the capability to do that. The cloud adds that utility to the product. And then the other cool example, and I love this one as much, this device is really a sensor, and it has the ability to communicate with so many other devices. I can manage and operate HVAC systems or the thermostat in my house. I can leverage this for my Fitbit or for other types of biometric monitors. I can see who's at my door. There's an unbelievable amount of, you want to call them Internet of Things, I just call them sensors. This device is now a portal into the physical world. Now, when you go to buy a piece of equipment, how many of you know if it has a Skylake processor in it? You don't necessarily know. In fact, the primary characteristic when you would make or purchase a piece of equipment has now changed. The primary buying criteria is whether or not it has access and can make use of the cloud. And the cloud is what is now bringing productivity and capabilities to all of this infrastructure. And that is where the gains will come, not from the sheer improvement in the hardware. And it should be that way, right? The cloud offers really unprecedented price performance capability, flexibility, resiliency, and scale. But what does that mean for us in this room? And I'd like to share with you just a couple of statistics, things to consider. In 2016, we will collectively spend $38 billion on cloud infrastructure. That's up 25% on a year-on-year basis. If you have any question about just how big this phenomena is, it's coming now. And it's only coming because all of you, all of us, collectively believe that this is the next wave. This is how we're going to get productivity in the future. Consider also that 80%, according to IDC, of the apps today that are being built in the cloud are being built for things we've never even done before. Things we may not have even envisioned that we wanted to do. Very exciting family and collection of applications that are being built in the cloud today. But what's coming next? Fast forward, and not far forward, but according to Gartner, by 2020, 30% of all the enterprise software vendors will either be cloud first or cloud only. That is the only way we will be able to consume those products. And very quickly, you're going to find that the likelihood of encountering an IT department that has a no cloud policy will be about as common, or I should say as rare, as finding an IT department today that has a no internet policy. But when I look at this 30%, I actually get excited, not necessarily by the 30%, but by the corollary, the 70%. The 70% is the much larger number. This is not cloud first or cloud only. This is going to be hybrid. This is the reality of ERP, of SFA, of CRM, of all the things that run our businesses today, that balance the books, that help us to invoice, that help us to open a service ticket, that make sure that our expense reports are done, that our paychecks get cut. All of these types of day-to-day enterprise backbone capabilities, 70% of those are going to live in a completely hybridized environment. So how do we get from here to there? I mentioned yesterday the number of workloads that are moving to the cloud is something like 200 million workloads between now and 2025. But today there are only 8 or 9 million workloads. This is going to be a huge shift that's coming. And I thought about imagery. I wanted to have a good image in my mind, put a slide up here for all of you that captured it in one place. And the first one that I came up with was a bridge. A bridge from point A to point B. A bridge from today into the future that incorporates the cloud. But the bridge is not quite right because this is not at all the way the migration is going to happen. We're going to have certain elements that may be burst to the public cloud. We may have private cloud instantiations. We have private cloud instantiations based on open source. We will still continue to have on-premise. The cloud is not a perfectly homogeneous event, and getting there is not as simple as crossing or building a bridge. And so I kept searching, and I came up with a Zen garden where you move from stepping stone to stepping stone, from one sanctuary, one idyllic sanctuary to another. But this isn't quite right either, is it? There's going to be a lot of tumult. There's going to be a lot of change. There's going to be a lot of things, a lot of technologies that we feel uncomfortable that we'll need to embrace. And so late at night when I was working on this, it came to me as I was watching television. The best metaphor is perhaps the one of the BBC program, Total Wipeout.
His head actually vanished. Briefly, it was gone.
That was brilliant.
That was brilliant. It gives us an objective to avoid, right? That we end up falling from pillar to post and end up wet and muddy and needing a few aspirin. It's a challenge that we're all going to need to go through. It's a migration that needs to happen. The project is going to offer us a lot of interest, but it's also going to be filled with pitfalls. And I thought I would share with you, and Sangeeta, who's going to come out right after me, is also going to share with you some more of the details about what are the elements of the solution that we think we can uniquely offer that are going to help us avoid a total wipeout. And the first one is this notion of ubiquitous access. Now, it doesn't really matter what our IT, what our corporate strategy is, whether it's led by networking or DevOps or whomever. The users, our customers, our partners, our vendors, our suppliers are all going to want to have ubiquitous access and a uniform experience no matter from where they are accessing our capabilities. Now, with our presence in the Fortune 500, in the Global 2000, I believe we have the best jumping off point to work with all of the different cloud vendors, just some of which we already have established relationships that support our product, our capabilities, that support iRules. We have the best jumping off point to help you make the migration into those environments. And they have, all of these companies, the utmost incentive to help all of you work with us too. This is something we bring to the table that we think you're going to really benefit from, and something that we feel that your users are going to demand. The second is security. Of course, all of these information assets are going to be dispersed. Devices are going to be dispersed and heterogeneous. It's going to get very complicated, and we're going to need to protect ourselves not only from threats that we do know, but also threats that we don't know. Collaborating and cooperating and integrating with all of the brands like this are something that we do very, very well. We offer a lot of core security capabilities, but we also open up to all of the vendors that provide ancillary services that leverage us to provide service chaining and to ensure that all of you get the absolute best security posture. And then lastly, I always say if it's man-made, it's going to require service, it's going to require support, it is going to break at one point or another. And it is not sufficient to simply hide behind an SLA of a cloud provider. You're going to have to insist, we're going to have to help you provide visibility down to the single IP address or down to the single server instance, to the single data path. This is a live example. This is a Splunk screen capture here that shows you exactly that. You can see exactly which IP address is not behaving properly. You're also going to want that to validate that SLA that cloud provider is offering you. And so this second chart down here shows you exactly that, the latency over time of a round-trip transit. And then I also mentioned security just a few moments ago. This is a live view right here of a DDoS mitigation. It's not enough to know whether you're being attacked or not being attacked. How did your infrastructure respond to that attack? And so those are all of the orchestration capabilities that we are going to help bring to your infrastructure. And so whether you're just putting your toe into that pool known as the cloud, or whether you're jumping in full force, we think we have a lot to offer. We think we can really help you get there. And we're anxious and excited about getting the opportunity to work with you on this momentous effort, and this effort that really picks up exactly where Moore's Law left off, and hopefully will give us another 40 years of the great gains that all of us have come to expect. And so with that, I'll part, but Sangeeta is going to join now and share with you all of the details underneath of this and explain to you exactly how the technology is going to help make that next wave in productivity a reality. Thank you very much.